Hello, welcome to this video / live stream, depending on when you're watching, where we are going to take a look at building our own WebAssembly cloud using the Fermyon platform. So first, welcome back to the Rockcode Academy. I'm your host, David Flanagan, although I go by the handle Rockcode across the internet. This course is kindly sponsored by Fermion. Spin is a really cool framework for writing microservices and full application composed of microservices using WebAssembly technologies. And Fermion are at the forefront of that. And this is going to be fun. So in order to get started, we'll pop up my screen share. And I want to set just a small little bit of context into Fermyon Cloud. And then we'll look at hosting our own. So I've kind of prepared a very simple Spin application. And in fact, when I say prepared, I used Spin New to generate the template that gives us a Hello World application. Let me bump that font size up because I was coding earlier, which is why it's smaller, which just prints Hello World. I've already ran Spin Build, but we can do it one more time. And we can use Spin Deploy to push this to Fermyon Cloud, which for now is free. So you get to deploy up to 5 applications on Fermyon Cloud, kick the tires on it, doesn't cost you a single penny. Now, because this is already deployed, we don't really need to wait for this. Instead, I can just come back to here, and I can see that the URL for this demo application gives us an internal server error, which is probably because I just redeployed it. But if we refresh it, we get hello Fermion. And that's it. Spin New, Rust code or JavaScript code, maybe some Go code, maybe some .NET, maybe some Python. You know what? With WebAssembly, doesn't matter. Write in a language that you enjoy writing in. We build it, we deploy it, all good. But what if we want to run it ourselves? And this is where I think Fermyon gets really interesting. Is that nothing Fermyon are doing is closed source. Everything is available in the open. And in fact, even Fermyon Cloud is just a collection of components which are also open source. And you can go to github.com/fermyon/installer, where you will find Terraform automation to run your own little Fermyon Cloud on Amazon, Azure, Civo, DigitalOcean, GCP, and coming soon, and you'll see the demo on Tuesday, Equinix Metal, because, well, I wanted to do some hacking and I've got a cool demo for you next week. So we're going to take this automation and I'm going to use the newest one, which I know is a bit risky, but Siam, who we all know in the cloud native space, who also works for Civo, put together the Terraform to deploy the Fermyon platform to Civo Cloud. So I have this cloned locally, and you'll see that I'm inside the Civo directory, which has a README if you really want to read it. Or you can just do what I like to do, which is go straight into the Terraform directory and run Terraform in it. This will pull down all the Terraform plugins that we need to do this deployment. I have already exported my Civo token into this environment, hopefully. So I should be able to run Terraform apply, which is going to spin up a instance. We can just quickly run through some of this. Yep. Which will spin up a firewall first, allowing some ports, pretty everything's pretty available by the look of it. A Stevo instance, which we have some custom user data, which we may or may not go through. And then we have the IP assignment, the network, the reserved IP, an SSH key pair, random password, blah, 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 blah. Pretty much we're in a position where we just want to hit yes and say go. So while this spins up, because it will take probably around 1 to 2 minutes, we'll take a look at that automation. Probably should pop this open. Oh, watch approval, thank you. And actually, we need a few directories up. So let's do code, blah. Now, each of these implementations for AWS, GCP, DigitalOcean, etc., really just handle the provisioning of the instance, the network, the firewalls, and then all of the user data is provided at this top level directory called share and then terraform. We have a VM assets folder, which the file provisioner will actually just SCP onto the machine for you, which contains a bunch of Nomad jobs. But before it gets to that, it runs the startup script. Now, I guess now is a good time to understand which components make up the Fermyon Cloud or Fermyon Platform. One, there's Hippo from Deis Labs. Deis Labs, Hippo. Yep, thanks, Google. This is a project for running WebAssembly. It's open source. It's still actively maintained. It's being worked on. Has an experimental warning, but of course, all the best projects do, right? So you can run Hippo, and you can ask it to run WebAssembly binaries for you. Another part of the platform is Bindle, also by Deis Labs. And Bindle is an object store for WebAssembly modules. Now, will we still be using Bindle in 3 months, 6 months, 9 months? I'm not entirely sure. Why? Well, go check out the Spin Watch New 0.8 video that I released last week. Fermion have added support for OCI registry for WebAssembly and Spin applications. So you can now just do a Spin OCI push, and your Spin application will be available via GitHub Container Registry, Docker Registry, Google Container Registry, and so forth. So where is Bindle in this? I'm not sure. It may be that it takes a back seat for something that is more generic and something that we're already using for our container applications. This opens up a really cool potential for having our WASM and our container Linux-based applications running side by side. Now, Bindle and Hippo make up the main chunk of what we need to build a WebAssembly platform. However, we still need to schedule these workloads. Now, there is some really cool work happening to run WebAssembly binaries on Containerd. And I'm not going to talk about it right now or show you anything with regards to that because it's early and it's not how Fermyon Platform works right now, or maybe ever, to be honest. I'm not entirely sure. But it uses Nomad. And Nomad is a HashiCorp project that doesn't have this assumption about the workloads it's going to schedule and orchestrate that works really well for WebAssembly binaries. And in fact, an interview I did with the CTO of Fermion was talking about how they were able to reduce the amount of code that they wrote to make WebAssembly and Crustlet work was in like the hundreds of thousands of lines of code, but the WebAssembly support for Nomad was dozens to hundreds of lines of code. So much easier to reason about and work with. It's not just Nomad that they use. Console is used for service discovery and for making sure the URLs work to browse to it because traffic sits in the front as a proxy, speaks to console as a discovery mechanism for all of the WebAssembly applications that are available, sets up all the routing for you, and any secrets that are required come from Vault. So essentially, this is a full Hashi stack with a little bit of glue on the top to make it work for WebAssembly. Okay, let's see where we are with our deployment. If you have any questions, feel free to drop them into the comment section, which I just realized I don't even have open. Where are my comments? Let's turn off No, it's not hiding up there. When was the last time I streamed? Nope, no comment window. Yeah. Where are you? Oh, I bet he is behind here. Oh. Right, I'm not going to look for it any longer because now I'm just going to look silly. But I have no idea where that went. Okay, let's check where we are. Okay, cool. So the terraform has completed. We know that because we have all of the outputs. So we have the bindle address, which we'll need in just a moment for pushing our spin application to. We have a generated SSH key, which will allow us to get onto the machine. We have the DNS host. So by default, if you don't provide a DNS name, it uses slip, which is really just you put an IP address on as the prefix, the subdomains of the main domain, and it resolves for you. There are loads of services like this these days. slip is just the one that is used as part of this automation. We have a Hippo admin username and password, which we can use to actually browse to the Hippo instance. So why don't we start there? Why don't we copy this? And what should happen is when we open this, is we get our own little mini UI for Fermion Cloud. Ta-da! Isn't that neat? So we can put in that our password is admin. We can pop back over here, and we could do terraform output JSON jq dot hippo admin password dot value, and this gives us our password. And now we can log in. Now we don't have any applications, we haven't deployed anything yet, but you know, this is very similar to just Fermion Cloud. Next, what do we need to do? Well, we need to push the application. So we can do spin login with a URL parameter. And this actually, oh, that's still the password. This takes the Hippo URL. So we can do hippo.212.244.17 From here, we can say whether we want to log in with GitHub or whether username and password. We do not have any OAuth configuration client set up for GitHub. So we're just going to use the same username and password that we used to get into the UI. And next, we need the bindle URL, which is the same as the Hippo URL, only with bindle instead of Hippo. So we can just do slip.io. And this will need a /v1 on the end. And bindle will be running publicly and unauthenticated. So if you are going to play around with running your own WebAssembly platform, just remember that it's not secure by default. And there are plenty of warnings in the README to say the same thing too. Now we can do a spin deploy. And because we're authenticated against this new Hippo server, it's going to push it to there. I logged into the wrong place. So we can do cd demo spin deploy. Now we could just give this a few seconds, but what's going to happen is we'll be able to refresh this. In fact, we can already see it here. And we see that we have our demo application here. Now we can get logs, we can set environment variables, we can tweak some settings, although they aren't really at this point in time. And we can see that it's still publishing, so it's actually not going to be available on this URL just yet. We pop back to the CLI, looks like it's finished. We have a link, it's the same one as here. And I'll open this in a split. And we can see we have Hello Fermion. So most of that was just me waffle chatting away. Terraform init, Terraform apply, and we have a WebAssembly cloud. That's pretty much it. We have our logs. There's not really anything there right now because we don't have any logging in the default application. If we want to add an environment variable, we could say name equals David. We could click save, and this becomes available to our application. So you can kind of just do whatever you want from this point forward. I am just going to point out one or two more things before we wrap up the session. You already know that Bindle is running on this machine and it is available publicly, but so is console. So let's click on the link for that. You know what? I think it's just available on the IP address. So let's try. No. All right. Let's get on this machine. So we need terraform output dash JSON. Oh, go back a directory. Terraform output dash JSON. And we want to grab the private key, which is Civo private key. So we can JQ this, only this time we want a raw value. That just means without quotes. We want the value of this, which is our key, and we'll write this to priv. Now, because SSH can be a bit funny, we'll chmod this to be priv. And I'm going to do a BSSH, which is just an alias that removes host key checking. Really handy for ephemeral instances where you don't actually care. We want to grab the IP address here. And lastly, we want to specify our private key. And we're in. We're now on the machine where the Fermyon platform is deployed. So we can run nomad status, which will show us that we have our application that we deployed. That's the UUID that's sitting there. We have Bindle, we have Hippo, and we have traffic. Now, if you're not familiar with cloud computing and cloud init and how all this works, is when we push the user data to this machine, it's pretty standard that you're going to find the logs and var log cloud init output.log. From here, you'll get the public IP address for the console, the nomad, the vault. So some of these are private, which means you probably need to set up an SSH tunnel. But I'm going to try the IP address on 8500 just to see if it works. And it does. Cool. It worked on my Equinix metal test. I'm glad it worked on my Civo test. Yeah. So this is public too. So just caveat, be aware, this could be a bad thing. Hey, oh, hey, I found my comments. There we go. Hey, Shupam, thanks for joining. And Hector.js, thanks for joining. So console is here. And from here, you can actually see all of the workloads that are running too. So you can see that we have console, Bindle, Hippo, etc. So if you do need to debug this at any point, you can kind of get in and take a look and see everything as you can. So just a word of warning, it is public. Please do not use the installer for any production-based stuff. You're really going to have to tie down those firewall rules and make sure that nothing, this is dangerous and it shouldn't be made available. And that's it. That's our demo for today. So check out the Fermyon installer. Run your own WebAssembly platform on any major cloud provider that is supported. If there's a cloud provider that you want to support, the repo is open source. Please feel free to open a pull request. Just need to write a little bit of Terraform. The great part is all the user data is global. It works on all of these providers, provided you use the right version of Ubuntu. So as far as the Terraform contribution goes, you only really need to spin up an instance on the cloud with some firewall rules, and it just works. So go check it out. I'll be back on Tuesday. We'll be doing the Equinix Metal demo, which I've been working on. This is going to show us how we can run multiple Fermyon platforms in multiple locations and use my favorite web technology, or at least networking technology, BGP, to do dynamic routing based on where you are in the world for super low latency WebAssembly workloads. So until then, thank you for joining me. Have a wonderful day, and we'll be back again soon with more spin videos as part of the complete guide to spin course. Have a great weekend. I'll see you all soon. Adios.